Now, okay. Now you can share your screen. We will start working on snapping head smash. Okay.
Okay.
Okay. Do you have any CAD geometry?
What did I don't understand?
Have you any 3D geometry on which we practice for snappy X mesh, or we can download it from Google?
No, I don't download any. I was using that maybe, no, but it's not complete, I guess. What I'm trying to maybe let's see.
Open it in ParaView. Open this in ParaView.
I guess it's not okay.
Open.
I was trying, but
If
what's
it is in an SQL form, then it will be open.
Was okay. Where is
Okay.
I guess it's not. I not finished, or it was
Click
some
over Z
damage.
positive. Click over Z positive axis. Click at the top Z positive axis. Click at Z positive axis. Yes, here. Click. There is no geometry here. Minimize
Yes.
it. Minimize it. Right click over this geometry. Right click. And open with. Click over at open with notepad. Open with notepad. Open with notepad. Browse more. And notepad. More application. More application. Yes. Notepad. Yes. Yes. This one. Notepad. The first. Yes. This one. Accept it. No, this is not CAD file. There is nothing.
Yes, I think it was damaged.
Yes.
Okay, I don't have other.
Okay,
yes.
then we have to create a geometry. Have you any other, or can I create a geometry for you?
Maybe I use that free cat.
Okay, open and make any geometry. Make any geometry. Make any geometry. For example, make a what should then I say about
That's other.
Make a sphere. First of all, make a sphere. Leave anything. Can you create a sphere here? Okay, create a sphere.
It's that seems like. I don't know.
Can you create a sphere here? Okay, close it. I think you are too weak. Close this one. Close it. Now close this thing. Stop your sharing screen right now. Just first of all, change this and share my screen. Now, can you see my screen?
Yes, I can see Wally.
Now just look, I am just creating a CAD geometry for you, okay?
Now we exit. It's free for download that software?
Yes, it is free for download. It is
Okay,
the
okay.
lesson software. Gambit is the lessons, okay? But Exceed is free. Okay, let me create a sphere for you. This is, and its radius is 5 meters. Okay, fly and a circle is sphere is 3. Okay, this is good.
Mhm.
This is a sphere. Now we will make its meshing. And now let me export this. Export as an IES file. Write a sphere as sphere. And accept it. And now IES is exported. Okay. Now let me close this one. Open my Rhino software. Let me convert it in this form. So the only thing matter here is that it is whether STL file or .obj file, okay? Because these thing matters here a lot, okay?
Mhm. Okay.
Okay. So this is my view here. The file. Let me open here. Open my desktop and go parallel. Now I will share that I just okay apply. Yeah. See here. See this. File. Open. Share that. The IKs contain error that is impossible to forget. Let me export it once again. File, export, steps, as the FDR, translational fair. Let me just export one more time. Change the state because I'm using an old version right now. Okay. And this time. And now let me export this for yes, step one, accept it. Now it is exported. Now let me close this. No. This one. And my take once again. That, 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 that. It's, let me close this one and open Rhino. I think
Mm.
I think I have an error. Let me see. I have another STL file, and let me open that for you, whether it's open or not. Uh, propeller. CSV. Okay, let me download it from here. Download get okay. Let's see. There are 2D models. I want a 3D model. Yes, there it is. It is popular 3D model. Okay. Let me download this thing for you. Can I download this 3D model? Download files. Okay. Let me download this file. And Facebook. Can I go through with this? Continuous release. Okay. Now I want to download that file, but where are they? Yeah, this one. So sign it and it. How can I download it? File? You see here, files are present. Computer to download. File. Already have signed in from. Okay, now I can download it. Desktop. Save it. Okay, now it will take a little time. Okay, it is around 5:39. It required around 3 or 2 minutes. Let it be download first, then we will start working on it. Okay.
It's okay, Wally.
This is a car, 3D car. We can work on this car. Even smart. Very good, I think. Yes. Okay, we will work on it. Let it download first. Yes, it is approximately done. Around it is 300 MB. It is completed right now. Yes, it is approximately completed. Okay, it's completed. Let me minimize it. And where it is? There. Okay. Now let me extract here and now where is this? Yes. Let me create a folder for it. Folder car enter enter and copy these files. Okay. And move them to this folder. Oh, what happened? Just copy, random copy, SLDR, even STR, assembly. Or,
I guess you make a copy.
okay. Now let me close this thing here. Now let me open Rhino and first of all convert them .stl form. Okay,
Mhm.
this is the new one. Index. File open desktop. And this is my step. Okay, guys. Okay. I think it is reading its file. Let's wait.
Mhm. I'll see that.
Yes. It is, I think, very heavy file.
Yes, it's a heavy file.
It is taking too much time. 28 police services up till now. It has written a vote of 44.
Mhm. Oh, it's okay.
Now it's going to be complete in just 1 second. Some assemblies have been random block is still to go off. Yes, some of them are there, but not all are there. Okay.
Mhm.
Just maximize this case and can I move it in right now? Yes. I want to get this section. Okay. Let me just close this and open anything else. Let me see first this files, LDR, and this is assembly part. These are parts. Okay, you can also add part. Let me open Rhino first. I H Rhino. Show you Rhino. Yes. Start from there. Third and whether it's open this file. I cannot see where it is. Cannot see in one direction. Anything.
It's not a long.
File. Open. This SLDR. Now I can see little animal is happening there. Okay, now I see two things this. Okay. Alright, okay. So, we have to oh my god, what is this? That is not different things. I want direct model in STL, but they are not in STL. Okay. They are not in this cases. I just want a direct copy. Anything here is remaining. Pictures, details, open. And STL, but at STL is not coming right. It's an STP step file. Whether it has an STP file. Yes, it is has an STP file. Whether it's open. Let me first check this one. It's open this, then it's good. We can convert it in STL. If not, then we can download from anything other. Okay. Open. Start. No, it will not. It will take a lot of
It's the
time.
same, I guess. It's the same file that a few minutes you open.
Now let me download anything else. Okay. It will take too much time. We have
Yes.
not so much time. We have only
If
1
we
hour.
if we draw maybe a sphere into the rectangle, it's possible? Or
Give me 1 minute. Let me download it from here. I can download it. Download. It. Okay. Let it open first. I think this is the best for this. Is this in a yes, you can see here there is a still present here. Okay. Now
yes,
let
yes.
me download this thing. Download. How much it is?
Oh, heavy.
Oh my god, it's around 1 GB. Let me see anything else for you. What about this one? The Formula One car. Hmm. What about this airplane?
I guess it's also heavy. No,
Um,
not.
yes, it is in STL form. You can see here small green landed model STL files. Can I download just simply this thing? Cancel this. Yes, I can download. Let me download it in directly. If it's okay, then it's 54 MB. Okay, it's good. We can
Yes.
download it. Okay, we can mesh this one. Okay.
It's okay, Wally.
Let me download it. I think it's completed anyone. Share will break on my screen. Okay, now it is downloaded. Let me minimize it here. Okay, no need for Rhino. Let me close my Rhino. Wait for this one. Okay. Where is ParaView? First of all, let me open my ParaView. And open this thing here. File, open, desktop, and CF desktop, and STL file, small green ladder names, all files, yes, yes, here. Okay, right here. Well, now I can see that. Okay.
Okay. Yes, yes.
Now let me just see its dimensions in different areas. And, like this. First of all, let me check its dimensions. This is great. Okay. Now, what is this? Next, let me just go. It's positive. So its direction along x-axis is 548. Okay. The maximum is 548 from point of starting. Where is the starting point? Let me define this thing here. Where is this thing? So let me just close this thing here. This two. Yeah. Okay. 5, 1. Desktop, someone. Here, right here. Okay, now the direction along y-axis is minimum. From here, now I can see this one. Okay. The maximum direction in y-axis is 548, 510. What about its center point? Center axis visibility. Let me see. Oh, okay. Its center is at the center of this thing. Okay. You can see. Yes. Center is at there. So the maximum point is this. So its direction will in positive x-axis. No, its direction is in negative x-axis. First of all, we have to create a snappy edge mesh for this. Then we can go for this. Okay.
Okay, Wally.
Now let me open Ubuntu first. Okay. That is MKVIR. What about this? Let me consider new. Let me do a simple card. This one LS CDSINTL. Simple card LS. Let me know where RM. CD constant LS CD polyPL LS. Yeah, okay, let me do it over. LS Right here, let me create here a directory one more mk space yes surface by surface. That's it. Now let me enter it. Now let me write as cd slash mnt capital U user desktop. In desktop I have a file SMA. Let me enter here and ls. Now let me see p minus SMA small model. Okay, okay, good. Let me start here, right here, home, Khalid, and simple car. In simple car, I have a directory constant, and then price efficiency. Okay, the file is copied. Now let me ls and enter ls here. Let me go to the directory simple car, simple car, ls. Constant enter ls. Let me go to the try cdtr try surfaces ls. Yes, now I have my file. Okay, it's a small dreamlander. Let me change its name. SML small dreamlander to airplane to plane .stl. That's it. Now you can see I have changed the name of the file. Okay, are you getting my point, Joseph?
Yes, you change the name of the
File.
file,
Okay.
right?
Okay.
But you started, you are extracting or you are copy from your desktop to the folder where we gonna do the snappy cache mesh. Is that okay?
Sorry, I'm not understanding what are you saying.
No, that you do now is enter or copy the file from your desktop
Yes,
to
now I
the folder
copy.
where.
Yes, now I have copied my file from desktop into Ubuntu terminal. Okay, this is first step. Now I will now, and the second step is I have changed its name from Dreamlander model to an arrow.stl. Okay.
Okay.
Okay, now I'm just going to create a basic snappy hexa mesh setup. In order to create a basic snappy hexa mesh setup, first of all, we have to define our boundary conditions. And first of all, we have to run a background mesh. In this case, a background mesh is a block mesh. We are going to first define our block mesh, okay?
It's okay, Walid.
Okay. LS here, now let me go back to data cd ls cd dot ls the system directory cd system ls. Now let me open my remove this case rm 0.33 ls. Anything else? Rm create batch, no need for me to create batch. Ls anything else more? Field averages. Okay, leave them, leave them. RM topo set. Let me remove my topo set from ls. Anything else more? Block mesh. Field average. No, let me open my block mesh. Block mesh take. Okay. So the block mesh is full here right now. Let me just remove everything from here. No need for arcs right now. Let me remove these edges from here. Now I have to set up my block mesh first of all. Okay, and then let me first of all, my first point is 0, 0. No, not 0, 0, because I see in my case the minimum or maximum points are not 0, 0, 0, 0 is the central point which is present here. Let me open ParaView and I can show you how I'm just going to create mesh for this small Dreamlander. Desktop, and where is that file? Yes, here it is file. Okay, and apply this. Now apply data access grid, center visibility. Or let me do this in positive access. Good. So what will be my inlet and position? So the minimum point is X range. Let me see from here. Is minus 27446 in X direction. So mean, what is your X direction? Your X direction is this red one. Okay. So the minimum point is this minus 27466. So we can do it this to minus 400 this and minus 400 to this one. Okay.
Okay.
So minus 400 and this is positive 400. So our first point will be in this case is 0. First point is, let me create here this thing and give this to 400 000 and what about my second point? My second point is this. Let me just go through this again. My first point is 400. So this is the maximum point in this case. It is difficult right now. First point in y direction is 400. This will be along minus 400. This is minus 400. 000 is the first point, and the peak point is it is difficult getting. Let me do this thing in here. Just wait for 1 second, okay?
Okay. Okay, Wally.
Yes. Point. My first point is 400. This point is 0. So this is my first point. Let me create my second point. Create point 400. And the next point is minus 400. Minus 400. Okay. And I see them here. X, Y, X, Z. Right now, I do not have a mouse, but I cannot zoom in or zoom out. Any option here? Window. Let me cross this thing. Cross this thing. Main block. Okay. Now let me remove these things. Action. Delete block. Block 0. Okay. Block 0. Okay. Block 0. Okay. logs are deleted. No, not like this. The first point is 400. Okay, and 00, 400. Let me just do it in my own way. Okay. The first point is 000. Second is 400. 000. Third is 400. And this is how much maximum which is required in this case. In case of y is maximum minus 280. Let me do this to 300, 350. Okay. So the maximum in this case is 350. This one is 0. And this one is 0. And this is 350. And that will be 0. Okay. So this is 000. And this is 5. And this is not 0. This is 400. Okay. And this is 400. Okay. And this is 350, not 4000. Let me remove them. 4350, 0, and this is 350 and 555. Let me press escape with colon WQ, CD dot. Let me write here. BLOCK blog MBS search blog. Let me check whether it works or not. Yes, it's worked. And good one. Let me ls here. Now let me go back to one directory. Right here explorer dot exe space and dot. There will be some little error, but we will counter it. Okay. Copy.
Okay, Wally.
Paste it here. Okay. There is the simple part. File open. Desktop. Sample code for S. Simple code. Edit on. Okay. Apply. Okay, so you can see. So this is the thing we have written.
Yes.
So the minimum point is our 000. We have to change our minimum point 0 to minus 400. Okay. And the what about the yellow one? The yellow is y1, and the minimum of, first of all, let us change that one, then we will see. Okay. Let me open my block machine. Here, CD, simple form, ls, CD system, okay, ls, vim space, secure block machine. Let me press I here and change this 0 to minus 400. Okay. And this 0 to minus 400. This 0 to minus 400. And this 0 to minus 400. Okay.
Okay,
Now,
Wally.
the minimum of y is 0. Now change this 0 to 350 minus 350 minus 350. And this 0 to minus 350. Okay. 0 to minus 350. Okay. This 0 to minus 350. Now 4 away. Okay. Now what is the maximum and minimum point of y? Z, sorry, not y. Z of this thing. Okay. So the
Yes.
maximum point of 0 is y is minus 71 to minus 81. So in Z negative when I check, so is it positive when I check? Okay. In Z positive, so its length is along like this. Okay. X is this, y, z is this. So maximum and minimum are top and bottom of this plan. Okay, top and let us do it 100 to both of them. Okay, minus 100 and 100. So the minimum is minus 100 minus 100. Okay, minus 100 minus 100 minus 100. This is the 100 and this is the 100. This should be also 100 and then this will be 100. Okay, now just let us see one. What is this? Where is the paraview? Yes, there it is. Now let me do it. We will change in the next case. Let me press escape, use colon, WQ, CD, dot, and LS here, and write here block mesh. Okay, it is created. Good. Now let me go back to one directory and write here explorer dot exe dot. Now let me copy the simple code. Copy and copy it. Now minimize and delete this one. Shift plus del. Yes. And now let me paste this thing new here. It is pasted here. And let me delete here this thing and delete this thing. Okay. Now positive X. Okay. Now let me open my ab.form. Okay. And apply here. Okay. Now this was my block. And let me open my aeroplane here and check its things here. Surface arrow.stl. Okay. And can you see right now your plan? Yes, your plan now is inside this box.
Inside.
Inside, let me just thing and let me do it off its capacity so we can see it. Okay, now I can see my aeroplane inside in this. Good. Now let me just do one or two more things. But what is that? That is the now I have to increase the value of positive y in my case. Positive y, positive negative. Okay. In that direction, in the positive y, I have to increase its value from 350 to up to 100, and I want to see this in thing. And top and bottom, I have also increased the value of z from 100 to 200, and x is okay. There is no need to change in x direction. I think x direction is okay, perfect. The only thing we need to change is here of y direction and z direction. In y direction we need maximum change, in z direction we need only little. Okay. Now let me open my this thing. Terminal cd simple as I am doing simple for ls cd system as system ls. And let me open my block my space block and in y direction of positive, let me do this 2000 first of all plus I and change this to what to 1000. Okay, and this up to 1000. Okay, and this thing up to 1000 and this thing up to 1000. Okay. And in z direction, let me do all these things into 200. 2 and 2 and 2 and 2 and 2 and 2. Okay, I think everything is good. This is the only background mesh. We don't need to do it. We can change this thing in. Or that cd dot ls and right we have block mesh. We are using to block. Okay, good. Let me go back to one directory. else here and write dx blo er dx is dot and enter. Good. Now let me copy my simple code from here. Copy, minimize this thing, and delete this one which is already present here. Okay. So let me paste my this new variant on my paraview. File open desktop. Here is desktop, and then desktop I have a simple card.
Simple color.
Open form. I have surface with edges. Okay. Let me store one thing is that which one capacity. Now let me open my aeroplane here. Okay. Okay. Now I have ready my aeroplane. Now we will start simulation of this aeroplane. Now what's the first step? Now the first step is we have to assign boundary conditions. Again, this will be my inlet, all inlet, and this will be my outlet, whether these are my walls or free stream boundary conditions, they depend upon me. But first of all, we have to assign boundary condition. And how we can assign boundary condition? You can see this is my which is my first point. Let me just draw here and tell you my points. What are my boundary conditions? 0, 1, 2, and 3. 0, 1, 2, and 3 is my this section. Okay. And then 0, 0, 4. I have to define it. Let me first of all define it. Let me stop my sharing screen and share whiteboard with you. From where can I share? Can you see whiteboard?
Yes, Walid, I can see.
Okay. Just give me 1 second. Okay. Okay, this is my whiteboard. Let me write here for you. Okay, this is my point 0. This is my point maximum 1. This is my point number 2, and this is my point number 3. Okay, let me draw one thing more. For example, this, and this. 0, 1, 2, 3, and this is my point number 4. This is my point number 5. This is my point number 6. This is my point number 7. So what about my inlet? My inlet are 0, 4, 7, 3. Okay. Are you getting my point?
Yes. Yes, Walid.
Can you see the I cannot share you. Okay, let me. Can you see the Ubuntu terminal right now?
No, I only had the whiteboard.
Okay, share screen. Share. Okay, can you see now?
Yes. Now, yes.
Okay, LSCD, SIMPL simple card, LS, CD, SYS system, LS, BIM space, BLOCK block mistake. And what about these boundaries? We have to assign boundaries. Okay. Let me go here. Okay. Let me write here inlet, enter, bracket, enter, one more bracket, and let me write here 0, 4, 7 and 3. Okay, 0, 4, 7 and 3. Okay,
Okay.
and then let me write one more thing here. Inlet, and what is my outlet? Let me just check my outlet first of all from this thing here. My outlet is 1, 2, 6 and 5. Okay, 1, 2,
Yes,
6
yes.
and 5.
Mhm.
1, 2, 6 and 5. Outlet is outlet is 1, 2, 6 and 5. Okay. Let me enter one more time and do this thing. Now this is not like this. Okay. And remaining will be my front and back line. And let me do this all thing as a walls. We can define them in different conditions. We can define them as a free fall boundary condition or anything else. Okay. Okay. Let me do this thing and right here. Let me stop share from there and share whiteboard here. This is 3762, 3762 and 3762, 3, 3, 7, 6 and 2. What was the next one? The next one is, let me go back to once again here there at whiteboard here. 0451, 0451. Okay, 0, 4, 5, 1, 0, 4, 5, 1. Okay, now let me share the next thing. What about next one? Whiteboard. Here. Okay, 0451 and 3762 are written. Now 0312, 0312. Are you getting my point, Joseph?
Yes, yes, I see that.
Okay.
I see your point.
0, 3, 1, 2. Okay, now let me stop my screen and this will be my last mode. Okay. Whiteboard. What about last is 4765. 4765. 4765. Okay.
Okay.
4765. 4, 7 and 6 and 5. Okay. Okay, now let me check whether I am doing in a correct condition or not correct, because the thing we are just missing something. Let me check from here in any system control boundary conditions. I exchange and mixing levels system block mesh. Let me open this with this too. Okay. I was checking what it says boundary condition. I just patch the patch but not boundary conditions. I'm checking right now my patches. Vertex rating. Yes. System block mesh on progress. Okay. Close. Empty front. Empty back. walls render patterns into plan. No, no, this is these are patches, not blocks, not boundary conditions. Just give me 1 second, okay?
No problem, Wally.
So let's show data tutorials. You can proceed. Server, sample form, sample for this one, right, outlet, okay. Inlet, okay, yes. Inlet type patches faces. This thing where we are missing. Inlet is like this type patches, okay. This was like this from the type wall, upper wall, district. Okay, well, the thing which is I was missing from here is the inlet, boundary inlet. Let me start from this bracket, okay? And after inlet, when I start this thing, let me enter once again right here, type, type, space patch, PADCH patch, colon, and then interfaces FACES faces, okay? And then let me write here enter, and let me give this boundary condition while and write here PY, type, PADCH patch, colon, enter, let me write it as FACES faces, okay? Then let me just go to here and write here walls, WA, double L wall, enter, and let me start from this thing, enter, PYPE type, and write here WA double L wall, enter, and this thing, and didn't close any of one after inlet. Yes, we have to close it. We have two of them, not one. Okay, first of all, let me just create this thing right here, and this thing right here, and this thing here, and close it like this thing.
Yes.
Enter, and this, okay. And one more thing is from here to from there, and close, enter, and this type wall, good, and let me close this thing, semicolon, enter, and do this thing. Okay, I think now everything is okay. There is nothing. Let me
okay.
just check whether everything works or not. CD dot and right here block mesh here. Block mesh. No, there is some error at line 60. Okay, start at line 60. Let me just go to back to system. LS BLOC block mesh at line 60. Where is line 60? Yes, here. We start from here and it's close. Okay. Good. Yes, it's closed by wall. Let me check here the wall boundary conditions. Type patch. Type double wall and faces. Okay. Yes, I have misses. Faces are misses from here. Let me write here and enter and write here FACES. Okay. Now everything is okay. Shift colon WQ CD dot log. Yes, it's log.
No.
Log okay, now your mesh is written. Let me ls. Let me go back to one direction. CD dot ls right here explorer dot exe. This was dot enter. Now let me copy this simple for you. Copy, minimize, delete this thing. Shift plus del. Okay. enter and paste here for you. Okay, and delete this thing, delete this thing, file open, and open aeroplane right now, apply, plan is here. Let me go back to directory at OpenFOAM, simple for, okay, OpenFOAM, okay. Apply. Now you can see inlet, outlet are here. Now let me enable only inlet, okay. So my inlet is in this case. Okay, we can change it tomorrow. Okay, this is my inlet and this is my outlet. Okay, they are just coming in different direction. I think we have missed anything. Okay, so
Yes.
inlet and outlet. Let me change them. And what about my wall? Let me apply them. Okay, my walls are this. So we have to change inlet and outlet tomorrow. Okay, everything's are
Okay.
clear. Okay.
Okay, Wally.
So tomorrow we can start snappy hex mesh of this aeroplane. Up till now, good. If you have any question today, you can ask me right now. Okay.
No, maybe if it's possible that when we made a snappy hash mesh, I practice doing from zero, or maybe with this ASCII file.
We can start from this file. We can share with you. Tomorrow we will practice on snappy hex mesh. Okay.
Okay.
If we use snappy hex mesh, we have to first of all define our block mesh. Okay. If we have no idea of block mesh, how block mesh is related with snappy hex mesh, then there is nothing to learn about snappy hex mesh. So for us to learn snappy hex mesh, we have to understand block mesh. And tomorrow we will start working on snappy hex mesh. We will give a boundary condition of wall to this aeroplane, and we will start simulation, and we will also make mesh from snappy hex mesh. Okay.
Okay, Wally. It's okay.
Okay, then good luck. Bye bye. Tomorrow we will have class at our time. Okay.
Yes, Wally. See you tomorrow.
Okay. Bye bye.